So in this next section, we're going to talk about curve fitting with quadratic models. Last chapter, so back in chapter 1, we talked about curve fitting with linear models, which was when they gave you an example of like 2 different data points. So in this year, the population was this much, and this year, the population was this much. And we used kind of data like that to write an equation for a line that represented the situation so that we could then use that equation to predict population in the future years, if the town was either continuing to grow or continuing to decrease the population. So we're going to do something similar to this, but we're going to talk about quadratic models now. So we're going to talk about how can we look at data points and figure out if it represents a quadratic equation or not. And then also if they give us points, like data points or just even regular coordinates, how we can take those and write the quadratic equation that they came from. So if I drew a quadratic that it would hit all 3 of those points, what would that equation be? So the first thing I want us to talk about is think about back to like the linear situation. Remember, linears are just lines, so straight lines. They either have positive, negative slope, no slope, or an undefined slope. This one starts with f of x, remember that just means like y, equals 2x plus 3. And this is saying as x increases by 1, by how much does your y increase? So if you were to kind of make a table, kind of see what's happening here, we're talking about our x values and our y values. And they're saying as x increases by 1, so let's say we start at 1, we go up to 2, and then 3, and then 4, we want to see what's going to happen to the y values. So if I take x equals 1 and I plug it into the function, so I come back up here to this 2x plus 3. I'm taking 2 times 1, which is 2, plus 3, and I get 5. Then if I put in a 2, 2 times 2 is 4, plus 3 would be 7. If I put in 3, 2 times 3 is 6, plus 3 would be 9, and then if I plug in a 4, I get 11 to come out. So as my x values are going up, remember we said that they're going up by 1, what are your y values doing? Good, they're going up by 2. So back in Algebra 1, and I just covered this with my Algebra 1 kids last chapter, they talked about this. They were looking at charts that kind of had data laid out like that, and the numbers that are increasing helps you find your slope. So remember, slope is always the change in your y's over the change in your x's. And the triangle there symbol, that means delta, which is Greek for change. Okay, so when they say change in y over change in x, they're talking about up here on my table, how much are my y's increasing versus how much are my x's increasing? Well, my y's are increasing by 2, my x's are increasing by 1, so 2 over 1 would just be 2, so that would be your slope. Where else do we see 2 in the equation? Back up here, where do you guys see 2 at? The 2x. So remember, this is in slope-intercept form. Y equals mx plus b. M is your slope. So when I looked at that linear equation, that 2, that's my slope. That's telling me that I'm going up 2 over 1, up 2 over 1 if we were graphing it. So we're going to take this idea now and apply it to a quadratic model, because this is linear. This would be forming a straight line if I graphed it. Quadratics don't form straight lines, they form those curved U shapes that we talked about. So for all linear equations, the x values are going to be evenly spaced. The first difference is always a non-zero constant. That means that it's going to be going up or down by a number. It's never going to be 0, 0, 0, 0, 0. For quadratic equations, the second difference is a non-zero constant. So we're actually going to be looking at 2 sets of differences here for the quadratic. Now, difference means subtraction. So we're going to be subtracting numbers in our table. We're going to be doing it twice to see if the second time, if we do it, if it's the same number, just like up above when we saw that they were going up by 1, up by 2. We want the quadratics to do the same thing, but we have to subtract twice If that second subtraction results in the same number, that tells me that it's quadratic. So let me show you how this works. You guys should have this data or this table here in your notes. So you've got x and y values. We're not going to worry so much about the x's. The x's are just going up by ones, because we're just kind of going across the graph. What I want to look at is the y's. So the first thing is, I'm going to take all of these numbers and I'm going to find the difference. Like how much did it increase or decrease by? So for 9 to 4, 9 was decreased by 5. So I subtracted 5 to get to 4. What did I subtract from 4 to get to 1? 3. Okay, then 1 to 0, I subtracted 1. Now 0 to 1, I added a 1. So I'm going the opposite direction now. 1 to 4, I added 3. 4 to 9, I added 5. This is what we call the first difference. What I'm going to do now is the second difference. So using these new numbers, -5, -3, -1, 1, 3, 5, I'm going to do that same process. I'm going to see how much did it either increase or decrease by. And what I want to see happen here is that I get the same number every single time in order for it to be quadratic. So if you're at -5 and you moved to -3 on the number line, did you add 2 or subtract 2 to go from -5 to -3? You added 2. Okay, so if you're on the number line, you're over here at -5, you had to add 1, 2 to get to -3. So we added 2. How about -3 to -1? Add 2 again. Now -1 to +1, you went to 0, and then you went to 1, so there's another add 2. 1 to 3 is adding 2, 3 to 5 is adding 2. This is known as the second difference. Since all of these numbers are the same, I added 2 repeatedly. I could keep doing that, and that would tell me what my quadratic function is. So this one's going to be quadratic. So if I don't get the same number, let's say I got 2, 2, 2, and then all of a sudden I got a 3. If it changes, even if one of them's different, it's automatically not quadratic. They all have to be the same in that table. So I want you guys to take a look at the second one in your guys' packet there and try it. Find the first difference and then find the second one and decide if you think it's quadratic or not. Okay, so let's talk about the first difference. What did you do to go from 1 to 2? Plus 1. 2 to 4? Next one. Okay, so remember that's your first difference. Let's take a look at the second one then. 1 to 2 is still plus 1. 2 to 4 is still plus 2. 4 to 8 is still plus 4. Oops. So that's not the same number. Okay, this is your second difference. It's not staying constant. That means that this one should have not been quadratic. So we would just say not quadratic for this one. Okay, there's one more on the next page, like on the back side there. I want you guys to try it as well. So 12 to 10, what's happening there? Good, minus 2. 10 to 9? 9 to 9. 9 to 10. Okay, you guys understand where I got those numbers from? Now we do it again. Negative 2 to negative 1. Plus 1. Negative 1 to 0. And 0 to 1. So what did you guys say? Quadratic or not? But this one is quadratic. Okay, so we touched on this a little bit already, but 2 points can determine a line, so a straight line. You probably talked about that a little bit in geometry, that you have to have at least 2 points in order for there to be a line to exist. Okay, if you just have 1 point, it's got nowhere to go. It's just kind of sitting out there all by itself. So there's got to be another point for it to connect to so they can make a line. Now, if we have 3 non-collinear points, non-collinear is something also that you probably talked about in geometry. That means that they're not all on the same straight line. That means that one of them is maybe off doing its own thing, and that line has to turn a little bit and create a curve in order for it to hit it. So that's how we get these quadratic functions, is when those lines start to curve a little bit and they change shape. They're not just a straight, rigid line anymore. So 3 non-collinear points, 3 points that aren't all in a nice straight line, form or can define a quadratic equation. So we can find the coefficients, the a, the b, and the c, so the numbers that sit in front of your x terms and that constant at the very end, by using a system of 3 equations, like we talked about last week when we were doing the elimination with those 3 variable equations. We're going to do something similar here with these quadratic functions. Now remember, your quadratic equation always looks like this. This is like the really general, generic form. Ax squared plus bx plus c. We've talked about a, b, and c a whole lot in this chapter because we use those letters for graphing, we use them for completing the square, we use them for quadratic formula. What we're trying to do is they're going to give you points, coordinates. We're going to use them to set up a system of equations so that we can find what a, b, and c are equal to, so we can write out our quadratic equation. So I'm given the 3 points 0, 5, 2, 1, and 3, 2. What I'm going to do is think of this equation, ax squared plus bx plus c. And instead of saying f of x at the front, I'm going to make that equal to y. Remember, f of x is the same thing as y. I'm just switching it so that it's at the bottom or at the back of the equation instead of the front, so that when I set this up, it's going to equal a number. Now, these coordinates, 0, 5, 2, 1, 3, 2, these are your x's and your y's. So when we get these set up, like for 0, 5, 0 is going to go in for all of those x values up there. So we're still going to have like a, b, and c left. And 5 is going to go in for the y. So it's going to look like this. You have a, and then in for x, we're going to put 0. So it's going to be a times 0 squared plus b, and for x is another 0. So b times 0 plus c equals your y, which is 5. So 5 and the 0 came from the coordinate. Then I do the same thing for 2, 1, and 3, 2. So for 2, 1, you're going to have a, and for x now you put the 2. So it's times 2 squared plus b times the 2 plus c equals 1. 1 is your y. And we're going to do this one more time for 3, 2. So a, and for x you put your 3, so 3 squared plus b times 3 plus c equals 2. So what I do next is I simplify up here what I can. So for this first one, a times 0 squared, anything times 0 is 0, so that's gone, and b times 0 is gone as well. I'm left with c equals 5. The good thing there is that c has been solved for us. So it's always nice when you have a 0 as one of your x's because it's going to give you c right away. So we've already solved for one of our letters. Now we just have to solve for a and for b. Now if I look at the second one, it's not as nice because I don't have zeros that cancel things out. So 2 squared is going to be 4. So I have 4a plus 2b plus c equals 1. Then for the last one there, 3 squared is a 9, so we have 9a plus 3b plus c equals 2. Now, since I know what c is, since I know that c is 5, what I can do here is actually plug that in to both of those equations, and then I'm down to a system with just 2 variables. So this is going back to like using that elimination method that we talked about last week. So if I plug in c, I would have 4a plus 2b plus 5 equals 1. And then I would have 9a plus 3b plus 5 equals 2. I'm going to move the 5s over to get them combined with those regular numbers. So for both of these equations, I'm subtracting 5. So the top one now is going to say 4a plus 2b equals 1 minus 5 is going to be negative 4. And then we have 9a plus 3b. 2 minus 5 is going to be negative 3. So thinking back to your guys' elimination that we did with 2 variables, this is when you have to get either the a's or the b's to match somehow. I don't really think there's going to be an easier one necessarily. I mean, maybe the 2 and 3 would be easier because they're smaller numbers, so you don't have to worry about like multiplying by 9. If I wanted to get rid of my b's, I would take the top equation times 3, because I'm trying to get them to be 6s now. And for the bottom one, I would take it times negative 2. That way they become those opposite signs so that I can subtract. Okay, so let's rewrite those now. The top one is going to say 12a plus 6b equals negative 12. The bottom one now is going to say negative 18a minus 6b equals 6. Now I'm going to add these equations. I do that so that my b's cancel. So I've got 12a plus 8a, which is going to be 20a, equals negative 12 plus 6 is going to be negative 6. Oh, shoot. Hang on. It's negative 12. It should be negative 18. That got erased. So that's actually a negative 6a equals negative 6. Then we divide by negative 6. We get a equals negative 1, a positive 1. So we have a is 1. We had c up above to be 5. So now what I'm going to do is go back to one of my equations, like back up here. Maybe use this middle one. So maybe I'm using this one here. And I'm going to plug in 5 for c and my 1 for a so that I can solve for my b now. So that equation said 4a plus 2b plus c. So 4 times 1 plus 2b plus 5 equals 1. 4 times 1 is 4, plus 2b plus 5 equals 1. So if we add the 4 and the 5, we have 2b plus 9 equals 1. Then I subtract 9. So I get 2b equals negative 8, so b is going to cost me negative 4. So now that I have my a, my b, and my c, those are those coefficients, I can write out my quadratic equation. So your quadratic is ax squared plus bx plus c. So a is 1, so it'd be 1x squared, or you can write just x squared. B is a negative 4, so it's going to say minus 4x, and c was a 5, so plus 5. This would be the quadratic equation that those points came from. What you can do to test this, to like make sure that you did it right, is you can take 1 or 2 or all 3 of those points. You can plug it into the function here, and it should balance out. So if I put in a 0, 5, if I put in a 2, 1 into my x's, and I balance that equation out, it should match on both sides of the equation. All right, we're going to do another one of these together here. This next one, we're not going to have c just given to us right away, because in the coordinates that they give me, I don't have a 0 for any of my x's. So I am going to have to do a little bit more work with this one, because I'm going to have a's, b's, and c's for all of my equations. So we're going to plug in 118 first. So remember, you're doing a times the x's, and then b times, or a times the x squared plus b times the x plus the c equals your y. So we're going to have a times 1 squared plus b times 1 plus c equals 18. Which, if we want to simplify this right away, you're going to have, this is going to be a times 1, or just a, plus b plus c equals 18. For the second equation, we've got 212. We're going to do a times 2 squared plus b times 2 plus c equals 12. 2 squared is 4, so you have 4a plus 2b plus c equals 12. And then you have 3, 2 for the last point. So a times 3 squared plus b times 3 plus c equals 2. So we have 9a plus 3b plus c equals 2. Now, when you guys do this, with ones like this where you don't get zeros for one of your x's and it gives you c right away, notice on all of these equations, all three of these, you just have c's. It's not like 5c, 2c, 3c, okay? They're all just c, c, c. So what it would be easy to do is pair up your equations, make one of them become negative, so take one of the equation signs a -1 to get those c's to cancel, so that you're back with just a's and b's, just like we had in the last problem. So that should, I mean, in most cases it should work out like that, because c you don't have to multiply by anything, so you should always be able to get rid of c first, right away, even if you have to do a little bit more work. So I'm going to pair up, like, equation, again, if you want to number them 1, 2, 3, you can. So this is 1, this is 2, this is 3. I'm going to pair up 1 and 2 and 1 and 3. We're just going to see what happens here. And really, you could do any pairing, it doesn't matter. So I'm going to do a plus b plus c equals 18. And I'm going to do 4a plus 2b plus c equals 12. And then I'm going to do 1 and 3. So a plus b plus c equals 18. 9a plus 3b plus c equals 12, or 2, sorry. For both of these problems, I'm just going to take the top equation times -1. I think that's going to be easiest because it's just going to change all those signs. So they're both going to say now -a minus b minus c, and then change the sign of that number. So that first one's -18 now. And then underneath it you have 4a plus 2b plus c equals 12. So let's add these equations together. C's are going to cancel. When you add, you're going to have 3a plus b equals -6. For the second pairing, I do the same thing. I get -a, -b, -c equals -18. Drop down that second equation, 9a plus 3b plus c equals 2. Add them again. C's cancel once more. And then I have 8a plus 2b equals, this one's going to be -16. So now we're back to two variables. We've got a's and b's here. I've got 3a plus b and that -6. I'm just going to bring that 8a and the 2b and the -16 over. If you guys can kind of think ahead here, b is probably going to be the easier one to get rid of. What are we going to take this first equation times, though? -2. That way it says -2b, and the bottom one says +2b. So I'm going to go ahead and multiply that before I stack them. So it's going to say -6a minus 2b equals 12. And then 8a plus 2b equals -16. And I'm going to add again. That gets rid of the b's. So I'm going to have 2a equals -4. Divide by 2. I get a equals -2. So there's one of my answers so far, one of the coefficients I was looking for. Now I need to find b somehow, so I'm just going to go back to this equation, plug in my a, so it's going to say 3 times -2 plus b equals -6. This is -6 plus b equals -6. If I add 6 over, I get b equals 0. So there's another one. Now I just need my c. For c, think back to that first equation that said a plus b plus c equals 18. So let's do that one. We have -2 plus 0 plus c equals 18. You're going to have negative 2 plus c equals 18. You're going to add 2 over and you're going to get c equals 20. Now that we have a, b, and c, we can write our quadratic. So it's a x squared. So a is negative 2, so negative 2x squared. Then it's b times x. Well, b is 0, so 0 times x is just going to be a 0. So you don't have to include it in your equation. You don't need to do like a plus 0. But then we have c is 20, so we're going to do plus 20. So there's your quadratic for this one. And there's no x term, like I said, because b was a 0, so it cancels out that term and it's gone.